So the gradient of a straight line is how steep the line is. And we can measure it using this formula here. So we call the gradient m for some reason. I'll not get into that, but the gradient's m, and that's what it is known as throughout. And it's the vertical change over the horizontal change. So remember that the horizon goes across the way, vertical lines go up and down the way. Or the wee h you might want to think of as a little line going across for the horizon, if that helps you remember which way around there. But hopefully you're comfortable with that. So let's look at how we would work that out. If we take these two examples here, and if we draw a little right-angled triangle, now it doesn't matter how big the triangle is, as long as it goes from a point to a point that's sitting on a wee crisscross. So if you forgive me, I'll not use a ruler because it takes ages to use the ruler on this. So that's one box and one box. So the gradient here is v over h. Vertical change is one box because it's going from 5 across to 6 across, 5 up to 6 up. And then the horizontal is going from 3 boxes to 4 boxes. So that again is 1. So the gradient of this line is 1. And if we look at the second one here, we do maybe this, and then we might choose this one here. And we do a wee right-angled triangle. So this is just to show it doesn't need to be, it just can be any of those points and make them into a right-angled triangle. So that's 3 boxes and 3 boxes. So m is v over h. The vertical change here is 3, and the horizontal change is also 3. 3 divided by 3 is 1. Now, this brings me to a problem here because we've got the same gradient, but one line's going up the way and the other's going down the way, so we can't have the same answer. What I need you to remember at this stage is that downhill gradients have negative values. So it's actually -1. Okay, so the gradient here is -1. What we could say is that this one is going across and down, so the actual the vertical change is actually a drop of 3, so we could write it like that. But you must remember any downhill lines have a negative gradient. So this formula here, v over h, in the drawing of the triangles isn't ideal. In a while we'll come on to, not in this course, but in a while we'll come on to a kind of slightly fancier formula that just automatically generates whether it's negative or positive, and you don't have to remember. But at this stage, you're going to have to remember if it's downhill, it has to be negative. So the other point to point out is that the 1 and the -1, if you think about it, you've got the coordinates on this, we're going across one box and up one box for each one. And so that's why it's got a gradient of 1. And so let's look at some more examples. So again, pick things that are on the crisscross. So I'm going to pick that point there and this bit down here and make a nice little right-angled triangle neatly as I can. So you should probably use a ruler, but honestly it takes ages. And then I've got 5 boxes and 4 boxes. So m is v over h. So the vertical change is 4, the horizontal change is 5. It's going uphill, so it's positive, and it's 4/5. The second one, I'll use this one and I think this one, and I'll make a little box, and that's 2 and that's 3 boxes. So m is v over h. The vertical change is 2, the horizontal change is 3, but it's going downhill, so it's actually negative because the vertical change was actually going down by 2, it was dropping by 2. So it was minus, too many negatives there. So actually -2, 2 over 3, which is -2/3. And here, let's look, we've got this one, and there's another nice one here and here. And so making that, so there's 4 boxes and 3, but it's actually a drop of 4. So m is v over h, and the vertical change, it's gone from 6 down to 2, so that's a drop of 4 over going from 2 to 5, which is an increase of 3, so -4/5. But just even if you're counting the boxes, that can be forgotten. So just make sure you check if it's going downhill from left to right, it is negative. And this one here, I'm going to choose that point and that point. And I'm just going to use my ruler here because that's quite a long line, but it takes ages to swivel round. So I'm not going to, just going to drop freehand. So that is 6 boxes and 1 box. So V over H. Try and write the formula down each time so as you remember. Vertical change is 6, horizontal change is 1. So the answer is 6. So this one has a gradient of 6. And perhaps you can see that these last two here, -4 over 3 and 6. So -4 over 3 is a top heavy fraction, which is greater than 1. 6 is also greater than 1. Any line that's greater, any gradient that's greater than 1 is going to be steeper than 45 degrees. So remember our gradients of 1 up here were a 45-degree angle. So that would be 45 and that would be 45. So, and these two here are both bottom heavy fractions, so less than 1, so they're less than 45 degrees. So you can check your answers. Okay, so sometimes you're using your formula to answer kind of real life questions. So here we have one. In order to pass building regulations, the gradient of a roof must be no more than 1.1. Will this house pass building regulations? And we have to give an answer. So let's look first of all at roof A. So the gradient of roof A is M is V over H. So the vertical change here is 4.8. And the horizontal change is 5.1. And if I use my calculator, 4.8 divided by 5.1 is 0.94. So that one passes building regulations. And then I'll do roof B over here. Should probably have done them the other way around. And the gradient is V over H, which is 5.6 over 4.9. 5.6 divided by 4.9, which is 1.14, which is too steep. So then we would want to conclude. So we'd want to say, so the house does not meet building, what do we call it, regulations in this question? You know, the rules for builders. Because roof B has a gradient greater than 1.